Hi everybody, these are the notes for Chapter 2 in Math 102. And Chapter 2 deals with set theory, so these are the examples from the PowerPoint to help you with your notes. And Set 2.1 talks about set and set concepts. And a set is a collection of objects whose contents can clearly be determined. So for instance, we can talk about like the set of Orioles baseball players. It's all the baseball players that are on the Baltimore Orioles team. Or you could talk about the set of integers, which are whole numbers and their opposites. So it has to be able to be clearly defined. And all of the members of the set, or all the items in the set, are called elements or members. Capital letters are generally described to name sets. So I could have, like here, for instance, set A is going to be equal to, and you can either write it out in words, you can write it in set builder notation or roster notation. So if I write it in roster notation, I just list the elements of the set. And you put brackets around it, not parentheses, but brackets. Or I could write it, if I do it in set builder notation, it is a bracket with an X, a straight line, and an X, which stands for the set of all X. The straight line stands for such that X is an element of, and we'll say natural numbers, and then we're going to give an inequality to describe it. So we'll say X is greater than or equal to 15. Okay, so that's another way. Or you can describe it in words. So I could say here set C is equal to the let me erase that real quick. Okay. So we'll say the members of Math 102. So on the previous slide, I talked about 3 ways you could list the sets. And here is 3 sets A, B, and C, that are listed, 2 with words and 1 in set builder notation. And they want us to write the sets using the roster method. So remember, the roster method is a list of the items. So set A is the set of natural numbers less than 3. Your natural numbers are like your counting numbers. So it's going to be whole numbers without 0. Your counting numbers are like 0, or not, excuse me, not 0, but your counting numbers are 1, 2, 3, 4, 5, 6. But think about it when you're a little kid. When you're taught to count, you never start with 0. So it would be 1, 2, 3. So if we have the set of natural numbers less than 3, I'm going to put an A because it's set A. And then less than 3, I'll put my bracket there, is going to be just 1 and 2 because we don't include 0. We don't go into any negative numbers. Now set B is the set of even numbers greater than 15. So I'll put my bracket there, and even numbers greater than 15 would be like 16, 18, 20, 22, and we can keep going infinitely. So really what we're going to do here to show that it goes infinitely is we're going to put the 3 dots after I-22, and then we'll close the brackets to show that it goes on forever. And then set C is the set of all X such that X is an element of natural numbers and X is greater than 5. So again, they want us to list it out. Since it's greater than it doesn't have the line underneath to include 5, we'll do 6, 7, 8, 9, and again, it goes on forever. So I'm going to put the 3 dots, the ellipse, to show that it goes on continuously. Now, briefly, because you will be seeing them, for your inequality symbols, remember, you read them from left to right. So if you have just an arrow pointing to the left, this symbol stands for less than. If I have the arrow pointing to the left with the line under it, it is less than or equal to. So that means it would include the number that is in the inequality. And then if the mouth, I call it the mouth, or the arrow opens to the left and it's pointing towards the right, it's either going to be greater than or equal to. So the line underneath is greater than or equal to, and just the symbol is greater than. All right, so here we're talking about the cardinality of a set, and the cardinality of a set is really just talking about how many distinct elements are in the set. And when you write the cardinal number for a set, you're always going to put a lowercase n and then the set in, like the letter that represents the set in the parentheses. So here we have n of a there. If I was looking at set B, it would be n of b. That's how you read it, and it really just stands for the number of, and here it is distinct elements. So if you have elements that repeat, it's not counted twice, so you're only counting the distinct elements. So if I look at set A and I want the cardinal number for set A, I'm going to put n of A will be equal to, and then I have, let's see, how many distinct elements? 1, 2, 3, 4, 5, 6, 7, and then 8. And I only count 13 once because it's repeated, even though it's repeated twice, because I want distinct elements. So n of A would be 8. Now for B, it's written in set builder notation. So actually what I would probably do first is write it in roster notation so I can see. And it's the set of all x such that x is an element of natural numbers and 2 is less than or equal to x, which is less than 7. So x can be 2 because we have that line underneath of it. So we have 2, 3, 4, 5, 6. And because x is less than 7 and they didn't put the line here, I'm not going to include 7. So if I count my elements there, n of b, my distinct or different elements are going to be 1, 2, 3, 4, 5. So n of b equals 5. Okay. When I give you a set, or when you see a set, they're going to ask you how many subsets or how many little groups of sets can you make from your original set. So let's say that my original set is going to be A. So I'll have A equals, let me erase this real quick. Okay. So we have A equals, and I'm going to make my set 1, 2, and 3. Okay. So to find the number of subsets, or how many different groupings we can make, you're always going to do 2 to the nth power. N, this is the number of distinct elements, so the cardinal number of the set. Okay, so, I'm sorry for my bad writing there. N here would be 3 because I have 3 elements in the set. So the number of subsets here would be 8. Okay, then proper subsets, you're going to do 2 to the nth power. So I'll do 2 to the third minus 1. So it's going to give me 7 proper subsets. All right, so here we're going to look at a Venn diagram, which is used to display information so we can see what sets have in common. Here is a Venn diagram where we have 2 sets. We have set A, which is right here, and set B. And then we also have the box represents the universal set. And the universal set is basically everything that's either an A, B, or in the box. So 2 and 4 would be in the universal set. So we're going to define a few things here. First, I'm going to start off and I'm going to list what the universal set is. And the universal set is everything that's in either A, B, or the box completely. So I'm going to start with the 2 and the 4 here. They're part of the universal set, even though they're not part of A or B. And then I have 1, 3, 5, 7, 9 from A. And then also included would be 6, 8, and 10 from B. Now, if I asked you just to list set A would be everything in this circle here. So it would be, and again, you list it with the roster method. So it would be 1, 3, 5, 7, and 9. And then set B is going to be everything in this circle. So 7, 9, 6, 8, and 10. Now, some other things that are talked about, and this is for 2-3, would be the complement of a set. And if you ever see, like set A, if we list that, but it has apostrophe next to it, that stands for the complement of the set. So basically what they're looking for there is they want everything, they want the complement, they want everything that is in the universal set, so up here, that is not in set A. So if I look at my universal set, 2 and 4 are both not in A, so they're in the complement of A. 1, 3, 5, 7, and 9 are all in A, so they're not included. But we also have 6, 8, and 10 that would be in the complement of A. If I wanted the complement of B, that would be everything that is not in B but is in the universal set. So again, I would have my 2, my 4, 1, 3, 5, and then the rest, the 7, 9, 6, 8, and 10 are all in B, so that's not the complement of B. So those are just some terms from 2-3 that you should be familiar with and know how to work with. We're also going to talk about the union and the intersection of sets. So if I ask you to find, I give you A and then I give you an N or an upside down U, B. If you see something written like this upside down U stands for the intersection of sets. So it is what the two sets have in common. So if I want the intersection between A and B, on my Venn diagram, it's going to be right here in the middle, what they have in common. So my answer would be 7 and 9. The intersection is what they have in common. I typically think of like a road. If you come to the intersection of two roads, it's what they share in common. There is also the union of two sets. So that would be written as A, U, B. And the U, the capital U here, stands for the union of two sets. And with the union, what you're going to do is it's all the elements in either A or B. You're going to put them together. So here I would start with A and list all of those elements. So I have 1, 3, 5, 7, and 9. And then go to B. Now I've already listed 7 and 9, so I don't have to list them again. But I'll have 6, 8, and 10. And that's the union. With union, I typically think of like a marriage, two people coming together, so they combine all of their stuff together. So the union, you put everything together. The key word for intersection is and. So see the word and, they're looking for an intersection. And the key word for a union is the word or. Okay, so here, this is part of section 2.4, and it's an extension of 2.3, but we're going to perform operations within sets. So we're going to do some problems where we're going to look at union, intersection, complement, and then do operations with those. So here I have listed the universal set. So this is where all the sets came from. And then we have 3 subsets of that. We have A, B, and C. And the first problem that I'm going to do is I want to find the union between A and B. So again, remember, that's where you put the 2 together. So the union between A and B would be 1, 3, 5, and 7, because that's everything in A. And then in B, what we haven't listed already is 2. Okay, so that's the union between the 2 sets. Now, the next thing I want to find, if you see something written like this. Okay, remember, this apostrophe right here means the complement. Because it's around, like there's parentheses around the A union B, really what they're looking for here is the complement to the union between A and B. So for that, we have to take a look at this set and then go up to the universal set. So up here and see what is listed in the universal set that's not in the union between A and B. So 1, 2, and 3 are all listed. 4 is not. 5 and 7 is there, but 6 is not. So the complement to the union between A and B is 4 and 6. Next, we are going to do this problem. So it is, okay, so if I read this, what they want is they want the complement of A with the intersection of the complement of B. So the intersection between the complement of A and the complement of B, which means whatever's in both the complement of A and the complement of B will be in their intersection. So really, to do this, I do need to first start and list like my complement of B, because I have A, but I don't have the complement of A or B listed. So I'm just going to do that down here. And the complement of A, if I look up to the universal set, would be 2, 4, and 6. So it's everything that's in the universal set that's not in A. And then the complement of B is, let's see, 1, 2, and 3 is in B. So the complement would be 4, 5, 6, and 7. All right, now we want the intersection for our answer up here. And that means what they have in common. So if I look, they both have a 4 and they both have a 6. So my intersection between the 2 complements is going to be 4 and 6. All right, let's try some more problems. Let's do, let's see here. Let's do A with the union with this. So really what they're calling for here is they want set A in the union with the intersection of B and C. So to do this, I always tend to think like use your parentheses first, like think of order of operations. So I'm going to find the union between B and C first before I can do the union with A. So if I look at B and C, intersection, excuse me, not the union between B and C, but the intersection between B and C. And the intersection is what they have in common. So B and C both have 2 and 3. Okay. Now I'm going to take this set and combine it with A because they want the union, so you put the 2 together. So my answer here is going to be, we know we'll have 2 and 3. And then with A, we're still going to have 1, 5, and 7. And I didn't write the 3 twice because you only have to write repeating elements once. Let's also look at, Here, this problem. Okay, so again, focus on the parentheses first. We have 3 sets here, and they want the intersection between A, B, and C. So we want to know what do all the sets have in common, and then they want the complement of that. So first I'm going to start with just the parentheses and find the intersection between A, B, and C. So then I can find the complement. So the intersection between A, B, and C looks like A has a 3, B has a 3, and C has a 3. A and B have a 1, but C doesn't, and then there's a 2. So the only intersection between A, B, and C, the only number that all 3 sets have in common is a 3. Okay, then they want the complement to that. So the actual problem, this was just the parentheses that we did here. Now they want the complement to that. So we have to go back, remember, to your universal set. And they want the complement to this set. So 3 is here. So my complement would be 1, 2, 4, 5, 6, and 7. So it's everything but the 3. Okay, let's try one more. And this one that we're going to do, we are looking for the complement of C with the intersection of the union between A and the complement of B. Okay, so again, you kind of want to break it down. I'm going to look at the parentheses first. So I need the union between A and the complement of B. Well, I have B, but I don't have the complement of B, so I'm going to list that out. Remember, the complement is everything in the universal set that's not in B. So the complement of B would be 4, 5, 6, and 7. And then I want the union between A and the complement of B. So that's going to be, let's see here. A is 1, 3, 5, and 7. And then the complement of B is 4. We already have 5. We already have 7. So 4 and 6 will be added. Okay, so now I have this part down here. I have this part right here, right here. Now I need the complement of C. And that is, they have 2, 3, 4, 5, and 6. So the complement of C is going to be 1 and 7 because it's everything in the universal set that is not in C. And now I need the intersection between these two. So what these two sets have in common. And it looks like they both have a 1 and a 7. So the intersection between these two is going to be 1 and 7. All right, so here we are finding the cardinal number for the union between two finite sets. And finite just means that the sets end. It's not something that goes on forever. And what you do to find the number of elements together in the union between A and B is you add the cardinal number of A plus the cardinal number of B, but then you minus the intersection. So what the two sets have in common, because if you just add them together, the cardinal number for each, you're adding in the repeated items twice. So here we have set A contains 17 elements and B contains 20 elements with 6 in common. So this will be our intersection right here. How many elements are in A union B? So we're going to do 17 plus 20, because that's set A plus set B. But then we have to subtract what they have in common, so minus 6. And when we add them together, 17 plus 20 will give me 37 minus 6. So my answer is 31. So the cardinal number of the union between A and B for this particular set is going to be 31. They have 31 distinct elements. So here is our last section, 2.5, and they're asking for survey problems, which basically what we're going to do is we're going to create a Venn diagram from a survey that was taken. So for this one, I'm going to draw my universal set, which is just a rectangle to contain the Venn diagram. So we'll always have our universal set. And here we surveyed 120 college students at registration. Of those surveyed, 75 students registered for a math course, 65 for English, and 40 for both math and English. They want us to construct a Venn diagram and use cardinal numbers to label each region. So here I have two different sets. I have set A, which is math students, and set B will be English students. So when I make my Venn diagram, because I have two different sets, I'm going to have set A and set B. And I'm going to label A math, the first one math, and the second one English. And then what you want to do is really you want to start at the back of the problem and work your way to the front. So I want to know how many did both. So I had 40 students that took both math and English. That's going to be your intersection between the two sets. So I'm going to put the 40 there. Okay, and then I'm going to work my way backwards. So now I have 65 for English, which means this whole circle right here needs to equal 65, because if I look at it total, I want 65. Now I already have 40 represented there. So to get the number that goes here, you're really going to take your 65 and subtract the number in the middle, what you've already put in there. So if I do 65 minus 40, I end up with 25. And those 25 students right here, they only took English. All right, and then we got to go back to my math students where I have a total of 75. So again, this whole circle needs to equal 75. So I'm going to do 75 minus the 40 that I already have. We're going to end up with 35. Now, there's one more thing we have to figure out. If I take and I add my three numbers that I have on here to find the union between math and English. If I add 35 plus 40 plus 25. 35 plus 40 is 75. 75 plus 25 will equal 100. Now, we surveyed 120 students, but we only have 100 represented on our Venn diagram right now. So that leaves us with a number to put out here. How many students that were surveyed did not take either math or English? In that case, because we have 100 represented here and we surveyed 120, my answer for the universal set will be 20. So I'll have 20 outside the two circles, but still in the same box. Okay, now for our last example here, we have a survey, this time of 80 college students, and it was taken to determine musical styles they listen to. We have 42 that listen to rock, 34 to classical, and 27 to jazz. Then we have 12 students listen to rock and jazz, 14 to rock and classical, and 10 to classical and jazz. 7 students listen to all three music styles, and they want us to construct a Venn diagram using cardinal numbers to label each region. So this time, because I have 3 different music sets or genres, I'm going to use a 3-circle Venn diagram. So we got to draw our 3 circles. And then I'll label them. Let's see here. We have rock, classical, and then jazz. Okay, and again, start at the back and work your way forward. So right here in the center is the students that listen to all 3, because it's where the 3 circles overlap. And if we look, we had 7 students that liked all 3. So that 7 is going to go right there. Now, I keep working backwards, I have 10 that listen to classical and jazz. So if I look where classical and jazz meet, it's right here. It's what they have in common. But I already have 7 listed there. So if I have 10 total and I subtract the 7, I'm going to have 3 in here. Because classical and jazz, they overlap right here. So I had 7 listed for all 3. I have a 3 there. Let's see here. 14 like rock and classical. So that overlaps right here. Again, I already have 7. So 14 minus 7 is 7. So we'll put a 7 right there. And then we have 12 students listen to rock and jazz. So rock and jazz overlap right here. And we have 7 listed there, 12 total. So that's 12 minus 7 is 5. Okay, now we keep going back. We have 27 that listen to jazz. So really what I want to look at is this whole circle for jazz. This whole big circle. I already have 5, 7, and 3 listed. So that's 15 people that are already on there for jazz. But 27 total liked jazz. So if I'm going to do 27 minus 15, that's going to give me 12 that only liked jazz. We'll do the same with classical. So we have 34 that like classical, and here's my classical circle. So I have 14 plus 3, which is 17. So I'll take my 34, subtract 17, and end up with 17. So 17 goes there. And then 42 listen to rock. So we're going to take our 42 and we'll subtract what we've already listed, which is right here. So I have 14 plus 5 is 19. And when I subtract that, I end up with 23. So there's your Venn diagram. The only thing we have to look at is our universal set. Do we have a number to put down here? So I'm going to go through and just add the numbers on my Venn diagram. So I have 23 plus, and then we have 7 plus 7 plus 5 plus 12, and then we have 3 and 17 left, plus 3 and plus 17. So when I add all those together, that gives me, I end up with 74 students total. So if I look, we surveyed 80. I have 74 listed on my chart, so I'm going to take the 80, subtract the 74, and I get 6 students that didn't like any of those styles of music.